This is a recording of a presentation that will provide an overview of the New Jersey Department of Environmental Protection's Solar Siting Analysis version 3.0. My name is Ryan Gergely, and I was the primary author and lead GIS analyst for this analysis and report, and the creator of the online web mapping application that we've published. This presentation will begin with a quick overview of some of New Jersey's climate and clean energy goals before honing in on solar and the current status of solar development in the state. I'm then going to spend a little bit of time discussing this concept of environmentally responsible solar siting, which really guides this entire analysis and the previous iterations that came before it. After briefly going over the previous iterations, we'll jump into the new SSA version 3.0 and the analytical methodology, results, and products. For background, it's important to provide a high-level understanding of some of New Jersey's climate change and clean energy goals, namely the Global Warming Response Act, which set a goal of an 80% reduction of CO2 emissions by 2050 using 2006 emissions as a baseline. Furthermore, the Clean Energy Act of 2018 set a goal of 100% clean energy by 2050, a goal which was recently accelerated to 100% clean energy by 2035 via Governor Murphy's Executive Order number 315. The 2019 Energy Master Plan and the Global Warming Response Act 80 by 50 Recommendations Report are also essential pieces of the picture, as they provide pathways and recommendations to achieve these clean energy and decarbonization goals, including recommendations for upwards of 32 gigawatts of solar PV development by 2050. In terms of solar, New Jersey continues to be a leader in the development of this clean energy technology, with nearly 5 gigawatts of solar installed to date from more than 200,000 individual projects. This capacity has the state ranked in the top 10 nationwide, behind much larger states like California, Texas, Arizona, and North Carolina. On a square mile basis, New Jersey is ranked second with regards to installed solar capacity, behind only Rhode Island. The figure to the right shows where we are along the pathway of achieving the 32 gigawatts needed by 2050, and how we will need to install more than 1 gigawatt annually over the next 26 years if we are to achieve that goal. At a high level, solar development in the state is currently incentivized under the Solar Act of 2021. This act set a short-term goal of awarding at least 3.75 gigawatts of new solar capacity by 2026 and established the Successor Solar Incentive Program to help facilitate this build-out. This incentive program is multi-pronged, with the Competitive Solar Incentive, or CSI program, and the Administrative Solar Incentive, or ADI program. I'm not going to dive into these too deeply, but in the interest of time, I just want to note that some of the programs do contain siting restrictions, while others do not. More information on these programs can be found on the New Jersey Board of Public Utilities webpage. So why is this important? Well, if we are to achieve the goal of 100% clean energy by 2050, New Jersey will need to install upwards of 27 gigawatts of new solar capacity. Historically in New Jersey, solar arrays have required roughly 3 to 5 acres of land per megawatt of installed capacity. So to put it in perspective, the 27 gigawatts of solar would require anywhere between 81,000 and 135,000 acres of land and rooftop space for the panels and their associated infrastructure. With this in mind, it's important to note that while solar is a clean energy technology with obvious climate change and environmental benefits, these benefits can be lost if the solar panels are not sited properly, which leads us to the idea of what we like to refer to as environmentally responsible solar siting. Basically, promoting solar in areas of the state that will result in limited environmental disturbance to ensure that open space, critical habitats, and ecosystem services are not lost as a result of this new development. The DEP has long been proponents of the concept of environmentally responsible solar siting. Shortly after the passing of the Solar Act of 2012, an act that was really instrumental in jump-starting the solar industry in the state, the DEP published its first solar siting analysis. The concept for this analysis was simple. Essentially, a preference for siting solar, either preferred, not preferred, or indeterminate, was assigned to land statewide based on the type of land that it was. This was done by leveraging the statewide land use land cover, specifically the Anderson codes that describe the various land use types. Despite the name of this report, it wasn't much of an analysis at this point and contained no GIS or advanced analytics. In 2017, this analysis was updated using the same framework, but leveraged the new land use land cover dataset that was published in 2015. However, with this revision, we ran analytics, including calculating the amount of acreage statewide that fell into each of the preference categories, and developed a downloadable GIS data layer and web mapping application, with the intent of providing solar developers, municipalities, business owners, and other stakeholders with insight into the most preferred and least preferred areas in the state for siting solar. It's important to note that these analyses represented the DEP's preference for solar and were not an indication of whether or not a proposed project would be approved or denied. The 2017 update has been widely used since its publication and has helped inform solar policy, but it was limited in the fact that it was outdated and only leveraged a single dataset as the indicator of siting preference. And so that brings us to our newly published Solar Siting Analysis version 3.0, which was published in June of 2024. This new revision follows a similar concept, essentially providing insight into the most and least preferred areas in the state for siting solar, but it relies on an enhanced methodology in analytics. Rather than being focused on assigning a preference based on a single dataset, this new revision considers additional datasets that were overlaid in order to develop a numeric siting score that serves as the indication of siting preference. So I'll now provide a high-level overview of the methodology for the SSA version 3.0, starting with identifying and compiling all of the component layers that were going to be considered in this analysis. Through conversations with subject matter experts across the department, 20 different environmental datasets were selected for inclusion in this analysis. All 20 datasets can be seen to the right here, and for the analysis, each of these layers would be given varying levels of preference. So broadly, things like building footprints, impervious surfaces, landfills, and other contaminated lands were largely looked at as being more preferred areas, as siting solar in these areas would result in limited environmental disturbances. On the other hand, things like preserved farmland, threatened and endangered species habitat, open space, wildlife management areas, flood hazard areas, and riparian corridors were seen as less preferred areas, or in some cases, even off limits to solar development. In some cases, these datasets were given a single blanket score, such as things like landfills being scored with a positive 30, while others were given tiered scores based on specific attribute values in those datasets, such as the land use land cover, for example, in which case scores ranging from positive 10 to negative 10 were assigned to each of the 86 Anderson codes in the dataset based on the type of land that they represented. Once each of these 20 datasets were compiled and assigned scores, they were overlaid on top of one another, and the values were either added or subtracted at the points of overlap, resulting in the composite score. So that's what you're seeing here. On the left, we have each of the 20 data layers that were then combined and overlapped, resulting in the composite score in the middle. And what you see here is that composite score is symbolized with higher scores showing up in yellow and green, and lower scores down into the blue and purples. This analysis was completed across the entire state, as seen in the map on the right, and looking at it at the state level enables us to see general trends, with higher scored areas following development corridors and lower scored areas being more prevalent in rural areas of the state. But much more nuance can be seen when you zoom into a closer extent. In the image shown here, we can see a large residential development to the east, and as we move west, there's an area with some large commercial development before getting to a highway that is flanked by what appears to be forested lands and some wetlands. If we then toggle forward, we can see what the previous iteration, the 2017 solar siting analysis update, looked like, with the 3 designations of either preferred in green, not preferred in red, or indeterminate in gray. Again, this was based solely off the land use land cover dataset. You can see that this previous iteration was helpful in identifying natural lands as being not preferred for solar development, but it really lacked definition and refinement. If we jump forward, we can see how the solar siting analysis version 3.0 looks for this area. And due to the high resolution of this analysis and the number of data inputs that went into the generation of the composite score, a clearer picture of siting preference is shown, with things like individual residential and commercial rooftops showing up in the brightest yellows, indicating their highest preference, and things like impervious surfaces and large parking lots and other contaminated lands showing up in some of the brighter green colors. Eventually, this kind of traverses down into the darker colors where many of the subtractors associated with natural lands are present, where siting would be less preferential. I mentioned earlier that a component of this analysis, in addition to creating the visual representation of the department's siting preference based on the composite scores, was that we were able to run analytics and quantify the amount of land that received each score. In total, we established 7 different tiers of preference based on those composite scores, with tiers 1 and 2 representing the most preferred areas with scores greater than 30, tiers 3, 4, and 5 generally being moderately preferred areas with scores ranging from 25 to -25, and tiers 6 and 7 being the least preferred areas with scores below a -30. Broadly, just over 10% of the total acreage of the state are classified within those top 2 siting tiers, representing the most preferred sites for solar from an environmental perspective. 38% of the total state acreage fell into the moderately preferred tiers, while the remaining 51 or so percent fell into the bottom 2 tiers, representing natural lands, critical habitats, and valuable ecosystem services where development should be avoided. So let's look at these siting tiers through the lens of New Jersey's clean energy goals. I mentioned a few times that the main goal for solar to get us to 100% clean energy would require 27 gigawatts of new solar by 2050, which would require anywhere between 81,000 and 135,000 acres of space. When we look at the results of this analysis, more than 500,000 acres of space have been identified in those top 2 siting tiers, representing the most preferred sites in the state from an environmental perspective. Things like commercial and residential rooftops, large parking lots where canopy solar arrays could be erected, landfills and other contaminated sites that could benefit from redevelopment in the form of clean energy generation. In addition, tiers 3 and 4 contain roughly 1.1 million acres of space, representing other marginal lands in the state where environmental disturbance would be limited due to the development of solar. All this to say that we can achieve the goals set forth without compromising our natural lands and the critical habitats and valuable ecosystem services that they provide. Now I'm going to quickly jump into a live demo of the solar siting analysis version 3.0 web mapping application that we created and published. Again, this has the ultimate goal of being able to provide solar developers or other interested individuals with insight into the most and least preferred areas for siting solar from the department's standpoint. But it also gives them the ability to analyze desired sites to get a full understanding of why it is either high, moderate, or low preference based on the analysis that was conducted. So if we jump over to our web mapping application, when we launch it, we have this splash screen that kind of gives a quick overview of what it is, has the link to the document. But if we proceed to the map, there are a number of different components of this that we can take a look at. First and foremost, we have this swipe tool that enables us to see that solar siting analysis version 3.0 layer. And you can see up here on the left, the legend indicating the higher scores in those yellows and greens and the lower scores in blues and purples. If you go anywhere in the state, you can zoom in. If you click a specific area, you'll get a pop-up that indicates what that area was scored. In this case, we have a positive 80 on this really bright yellow spot right here. We also have the ability to toggle on an aerial imagery base map to enable us to see what is going on underneath this layer. You can see individual buildings, or in this case, this landfill right here. You can see how that looks with the aerial imagery. Down here on the right, we have all the different layers in here. So in addition to having that composite score layer, we have each of the 20 component layers that went into the analysis that can be toggled on or off so that anyone using this can get a good understanding of why, for example, this landfill was scored with a positive 80. In this case, toggling on the solid waste landfills layer, you can see that. Same thing, I believe there's a deed notice on this site. It's also a contaminated site. So as you toggle these things on and off, you can see that layer pop up and get a good understanding of why an area is being scored the way it is. Similarly, if we look over here, we have some really dark purples, which are actually down in the -80 in some instances. We can do a similar thing and see some of those subtractors, things like riparian zones, various flood hazard areas, threatened and endangered species habitat, where all of those subtractors overlap to get down into those negative scores. So using each of the component layers and being able to view that enables you to get a good understanding of why an area was scored the way it was. In addition to just the component layers, we have other helpful data layers in here, like the county boundaries, municipal boundaries, parcel boundaries. So if you're looking for a specific site, you can see those different overlays, electric territories, overburdened communities in the state, just other helpful data layers that can go into here to provide information. We also have integrated hosting capacity from each of the electric utilities. And what this does is toggling these on provide an indication of whether or not or how much solar could be connected to the grid at each of these nodes. So that's really helpful information from a developer standpoint if they're looking to develop a site to be able to see, at any given one of these nodes, how much solar could potentially be connected to the grid without needing to do any sort of upgrades. And that information comes directly from the 4 investor-owned utilities in the state. We have also recently worked with the Board of Public Utilities to incorporate prohibited lands under the Competitive Solar Incentive Program, the CSI program that I touched on earlier. So this program is kind of leading the way with regards to solicitations for solar moving forward, for large-scale solar. So some of the prohibited lands for this program are things like Green Acres Open Space, Pinelands Preservation Area, Pinelands Forest Area, wetlands in the state, the Highlands Preservation Area, forests, prime soils and soils of statewide importance located within agricultural development areas, and preserved farmland. And so what we've done is we've incorporated each of those layers in here under this group of prohibited lands. And if you toggle that on, what it'll do is it essentially shows those areas blacked out. So, a developer can quickly and easily see what areas may be, prohibited under that program and make those informed decisions on whether or not to try to develop a site that would be, otherwise prohibited for incentives under the CSI program. So if I just switch back here real quick, just to wrap things up, if there's one thing to take away from this presentation, it's that while solar PV has its benefits, we really need to be diligent in siting to ensure that those benefits are not lost and unnecessarily environmental disturbances are limited wherever possible. I've included my contact information here if you have any questions and would like to follow up. I've also included a QR code to our solar webpage where this report and mapping tool can be found. Thank you.